I don't know what to make of this. We're going to do this live. I need to go look it all over, see what the deal is. We got some kind of ray, some kind of beam, some kind of, I don't know. I don't know what it is. Some kind of ray, some kind of beam, some kind of something. Going to a regional subsector view of here. And we're looking at the natural color fire view. Right here. Coming off of this, going up and out, or coming in from this and going down and in. There is no doubt about it. You need to turn on your brightness. If you can't see it, you need to go over and look at the image yourself. We're going to go to a regional sector and look here. I do not know what the hell this is. Dude, this is just going from here up to Nevada. No, it's going beyond. It's fading out by the time it gets up to Oregon. There is a beam of some kind showing up as a heat signature. Look at this thing. Look at that. I'm going to hit play. Hold on. I'm just going to hit the last 48 images. We don't need to look all night because we looked earlier. Okay, this is sunset. What the hell, man? It's going through the clouds. It's going through the clouds. Look, it's fading in and out with the clouds. Do you see that? Look at that. Guys, there is some kind of beam. What the hell is going on, man? This is insane. What is... I am not joking. You go over and look at it your freaking self. It stopped at the ocean. It doesn't go out in the ocean. It doesn't go beyond. Let's go look at a full view here from our regional view. It goes right down to the coast. It does not go beyond. It goes from the fire out and away, and it fades out by the time it gets up here. It's being illuminated. A heat... Look, it kind of comes in like a spotlight. Look at that. What is going on here? Let's go up to Northern California. Look, it's going across the other image, this is from the goat. Look, it just kind of fades in. Look at that. Let me add some sound effects. How far north does it go? Look where it stops. Or it starts to fade out right here. Let's just... Oh my God. What's there in Oregon? Does it go further up to the north? Let's go look at a continental sector. You can even kind of see it from this far out. Oh my God. What is that? Okay, we got to go up and look into Oregon and see where it's pointing to, because it does go right into here and it just stops. So let's go see. Let's turn on our county lines. I have never seen anything like this. This is crazy. We were just talking about directed energy weapons earlier tonight. So here's the shape of the county here. This should be pretty easy to find. You see how this county is shaped like, well, a diagonal line that goes across, or not a diagonal, a vertical and horizontal line. So that should be pretty easy to find up here in Oregon, and just look over to the east of the county line to go see what's there. My God, what is going on here? Directed energy weapons. I know people are, skeptical about that. I'm not. At all, I'm not. I've done a lot of research on the topic. I'm 100%. Back in the 1980s, Lieutenant Colonel Thomas Bearden talking about directed energy weapons coming over from Russia. Okay, what's over here? Let's turn on our county lines, make sure we've got them all on. Here and just to the east. Going into Silver Creek and Diamond Craters Volcanic Center. Diamond Craters and Silver Creek. This is where the Malheur National Refuge standoff took place. Diamond Craters, Malheur. Here, let me see where the Malheur Refuge is. It might be kind of far away from there, but it's right around here somewhere. It's the only reason I know about the area. Yeah, there it is. So it's pointing into the Malheur National Wildlife Refuge, which is the place where they were doing the gold mining and the uranium mining for Uranium One. Do you hear me? You remember that? The beam is going right to it, guys. The beam is going up to Malheur, or it's coming from Malheur and going down to the south and going down into California and zapping it that way. Either way, the beam is going from California's fire across California. You can see the beam here. It fades in slowly over the course. This is over the course of about an hour. Here we go, about an hour. That beam is fading in, and it goes up. Either it looks more intense coming out of the fire, going up to Malheur, and it fades out by the time it gets to Malheur. But it could be the other way around, where the beam is coming from Malheur, and it's being targeted down into California as an over-the-horizon. This would be bent. This wouldn't be just a straight line. It would be shooting up in the ionosphere and then coming back down. Let's go look at the shortwave infrared, see if it shows up on that. Not showing up on shortwave infrared, or not very well. I should say not very well. No, it is. It is. It is. Right through here. Let's go see if we can turn on a different view in near infrared. Maybe that'll make a difference. Yeah. Oh, yeah. Oh, yeah. Oh, look at that. Look at that. Now you can really see it. Near infrared shows it. Look at that. Bam. Look at that, guys. Here, we're going to turn this. I've never seen anything like this before. This is directed energy weapons evidence. First time ever captured live. Look at that. For Christ's sakes, look at that. My God. Of all the people to get to capture it, Dutch since me. Wow. Wow. Look. And it goes out to the west, doesn't it? Hold on. No. So we have a little static in there as well. Don't confuse the beam with the static, okay? So let's just make sure about that. When people are looking at that, there's static going east and west that's kind of glitching in and out. This is not a glitch in and out. This is over the course of an hour, shooting from the fire, going up to the Malheur, and I just looked it up. It is a direct match. It goes into the area in between Diamond Craters and Silver Creek. It's going in right here. Here is that shape of the county, and it's going somewhere right into here. So either it's coming from here or going to here. But it's going from here, down and across, down to the fires in California. There is no doubt about it now. I just, for the life of me, guys, for the life of me, man, this one even goes conspiracy level for me. I would say, what the hell? Okay, I'm not faking this. You can go look at it. You can go look at the screen. You guys can go check it yourself. The website address is easy to get to, and let me show you how to navigate this site so you can find it yourself. Weather.cod.edu. Today is September 8th, 2020. It is 1:07 a.m. Central Time, and the time marked on here for this beam showing up, let me get it in UTC time, and look at the timestamp down at the bottom. Beam starts to show up right around here, which is September 8th, 2020 at 5:26:17 UTC. Then it carries on and gets more intense. It starts to fade in and out as the clouds are going through, and it is going up until now, the most current image, at 6:01:17 UTC. So we're talking for like an hour here. This has been going, and the beam goes up across all of California, probably up at an arc or an angle, and bounces off the ionosphere, if this is what I think it is. Since it's showing up on infrared, we can then put this up into, let's say, well, we can put this into the radio wave spectrum. So, infrared can show up, radio waves can show up as infrared can show up on radio waves. Long story on that. Let's go look at the regional sector view. Or, regional sectors. Whoops. And start in California and just look up. So we're looking from here back down to here, and let's just hit play. Okay, the beam is really hard to see at a very long distance. Look at long wave infrared. See if it shows up on long wave infrared. Not much showing up. Let's go to a sub-regional sector view. Look at the same area. We're looking right across going up through here. So it's not showing up on long wave. But it is showing up on... Is it showing up on short wave? Not showing up on short wave. But it is showing up on particle size near infrared. Perfectly near infrared. Infrared, of course. Of course. It's some kind of infrared weapon. Infrared creates heat. IR. An intense IR laser of some kind. And it would be beaming, they would be beaming out then from Malheur. From here. Beaming out from Malheur. Yeah. Beaming out from Malheur. Down to the fire area. Let's go look at the Cirrus near infrared. I can't believe I'm capturing. This is like sci-fi level, man. People wouldn't even believe it you would never believe it. If I didn't have this going live right now, I would try to tell people and they'd be like, yeah, right, Dutch. Yeah. Beam going across out of California. Yeah, sure. Yeah. Well, you can go look for it yourself. The best people could tell me is this some kind of mistake or some kind of anomaly or something. Why would an anomaly just go into the fire only? Oh my God, here. Okay, so particle size near infrared is showing it really well. Cirrus near infrared is not. True color natural fire color view is also showing it. Natural color fire view is how I first saw it. It was a red beam going across, and I thought it might just be some kind of, glitch or something. This is going for more than an hour at this point, and it's fading in and out, going through the clouds. Watch it again. We're going to go in real close. We're going to go right down here in Central California where it starts. Or wait, we have to go just a little bit south. Here. It starts right there. You can see it. And we're going to take it back the last hour. Well, I'll just hit play through the whole thing since sunset. And there's where it starts. It gets pretty intense. So here, let me slide this forward and back. Look at that. And it's not a glare off the fire, guys. We don't get a glare off the lens on the fire. That is going through the clouds. Look, it's fading in and out through the smoke and clouds. And it goes up to here, to the Malheur, which is the craziest place of all for it to go to, of all the dang places, man. Because that's where the big standoff happened. A bunch of people with guns and stuff went up there and had like some big fight out under Barack Obama. You remember? Oh my God. Go back to particle size near infrared. I mean, that's where it goes to. Go back down across Central California. There it is. Going right down to the fire. All right. There we go. You guys got to see all this? Good. Perfect time for me to sign off. I am saving this as a video, and I might as well upload it. We'll go upload it over on YouTube, and I'll provide the links to you guys. Oh, I said I was going to show you how to navigate the site. Hold on. So, over on College of DuPage, when you type in weather.cod.edu, I'll just give you a quick tutorial here. Weather.cod.edu, you go to Weather Analysis Tools, click on it, and then click on Satellite Radar. That'll open up this view with the multicolor view. And then we come over here on the left-hand side, and this is going to give you all your regional sectors and the areas with the little dots that we can select. We'll click on regional sectors, go over here on the West Coast in California, for instance, click there, and then go into particle size near infrared, and there it is. And then we can just hit play. It'll automatically default to 24 images, but you can change that to 96 or 200 images. Let's do that throughout the day today. See if there's anything else that happened. course, we've got the big fires. This is cutting out most of the smoke, by the way, which is good. There's our static glitching, which we expect. There it is. So you can see it. It's a slam dunk. I don't know what to make of it other than it is an energy signal. Near infrared, showing up in infrared, going from the fire in California, which we know there's nobody there. Obviously, it's a huge fire. And the beam is going back up to Malheur, or in between Diamond, what was the name of the place? Crater of Diamonds and Malheur, going right in there somewhere. That would mean somebody has something there that's targeting and going and shooting down into California, causing the fires or accentuating it. What else would you do with a high-powered infrared beam of some kind? You wouldn't be using it to look. And why would they be using it from Malheur National Wildlife Refuge? You know what I mean? Why? I mean, nobody can explain. How could anybody explain that to me as being normal? There's something up. Somebody's got to look into that. U.S. Armed Forces, somebody. Cops, somebody. You got to go look into it. I mean, what are we supposed to do? Are we supposed to just ignore an infrared beam coming from the Malheur National Wildlife Refuge pointing down into California? Are we supposed to just think that that's chance or coincidence? I don't. Anyway, I'll tell you what, tonight couldn't get any weirder. This is the weirdest night. Where's my popcorn? I need to get some more coffee. It's only 1 a.m. I'm going to be up the rest of the night with this mess going on. We have to wait and see where this beam goes. Does it happen again? Has it happened before? Is it an anomaly? Is it some kind of computer error? If it's a computer error, why is it a beam just coming out of the fire and going up to Malheur? Why Malheur, of all the places, for crying out loud? I don't want to think about that place because somebody got shot. Another person with a bunch of retards went up there and got into a fight with the government. And I can call them that. I can call them the R word, guys. Those people were so dumb. As a matter of fact, let's not even disparage people who are disabled with the level of stupidity that happened with those people that went up to Malheur. Okay? So, the people who are mentally disabled are not nearly as bad off as the dummies who went up there and thought they could go fight the government with their guns. Okay? So, the fact that there's a beam coming out of there is something that I'm just going to have to say it. That's just... I mean, this is direct evidence of a directed energy weapon. So who's got a directed energy weapon up in Malheur National Wildlife Refuge or between there and Diamond Craters? And how are they targeting it? Are they bouncing it off the atmosphere or ionosphere? What the heck kind of technology are we talking about here? Is it from space? What if it's just something, what if it's from coming up from up above? Hold on. What if the beam is coming from up above and coming down, and the thing, whatever it is just parked over southeast Oregon, over Malheur and Diamond Craters, and there's a satellite up in space that's beaming down that infrared beam, and we're looking, because it's 2D, we don't see it 3D. That beam could be coming down at an angle instead of going up, and that could be an entirely different story, in which case somebody's got a satellite parked over the United States, and they are zapping down to the fires in California. Which do you want to go with? Those are your options. Okay, well, you got 3 options, actually. Mistake, weird coincidence, going to Malheur. I don't buy it. So then our other 2 options are a ground-based energy source or a space-based energy source, because it's happening from the same spot for over an hour. Yeah. Somebody talking about Skynet. Yeah. We could talk about Skynet. Not now. All right. You guys, it's going to take a team of people to watch this. I would suggest you look for weird things like that, because it's going to take more than just me to find out what's going on now. This is to a level where, I don't know. What do you want me to say? I don't know what to think. It's some kind of energy weapon of some kind or a mistake. And the chance of it being a mistake, going to Malheur? No. So that rules, we can just by the process of deduction, rule out a few things. And, the chance of it going back to Malheur, that is the most controversial place in the world where they're off limits completely because of what happened. It's just freaky, man. Of all the places. All right, we're done. Peace out. Word up. Much love. And it's where their uranium is, too. 1:19 a.m. Central Time on the 8th of September, 2020. Peace out. New Jersey. Okay, so that being said, let's just go open up a window capture here and let's just hit refresh. Make sure we have the most current images here. What I want to draw your attention to, we're going to go back to the start of the day. So here we are. This is just before sunrise, West Coast. And over here on the West Coast, if you can't see this, I will zoom in on a closer view in just a few, but you might have to be on a computer in full screen HD to see this in full detail. But these red splotches here are going all the way down through California, but we got to look at this smoke. That's really what I want to show you on this. So here we are this morning, and sunrise is coming through, and over here in California, what you'll see is a poof of something that goes up above the smoke. Watch this. And it leaves a shadow down below onto the smoke. That is a poof of moisture that shows up of a big water vapor that's, I would estimate, at least a few large lakes worth of water puffing off at once in a giant steam burst. And it's white. It's not a pyrocumulus either, guys. So look at the smoke, though. Look what's happening here. So yesterday, let me take you back to yesterday. Here we are yesterday morning, and the dust storm that blew across Oregon and California mixed with the smoke and blew out down here, and that's kind of what we're seeing here. All this milky is actually residual smoke. This is yesterday. So we go throughout the day yesterday, you see the smoke really start. The wind shift, because of our low pressure system here over Colorado, it's a counterclockwise rotating low pressure system here. You can see that. See how it's rotating counterclockwise? That's normal for low pressure systems. So as it's rotating this way, it's pulling cold air down in from the north and pulling it back in and around, and it pulled in a bunch of cold air down and then pushed it back into Colorado, creating a bunch of snow up here. Well, now the low pressure system, watch it. This is last night. Throughout the night, last night, here we are this morning. The low pressure system is parked in place and is rolling back north, or, well, actually it's rolling to the west by southwest. It's kind of staying in place right there. So there's a counterclockwise rotation that pushes up and around this way, and it's blowing all the smoke out into the Pacific. But that's only partially of what's happening here. All this smoke now, look what's happening. It's pooling up because of the greater trade winds, if you will, or the greater jet stream coming in from the west, that it's kind of sandwiched in between the low pressure system over the Rockies and the winds coming in from the west, and the smoke has nowhere to go. So now what's happening here is that it's starting to combine with the moisture along the coast, and we're getting it's starting to form in, I don't even know what to call this. It's starting to form into its own smoke low. Okay, we're going to have to come up with a new term for this. Watch the rotation as it starts to form out here on the West Coast. You'll start to see it right on the last few frames, right here. So that's over Northern California. Let me bring it in a little bit closer now, and you might be able to see a little bit better what I'm talking about. We'll go into a regional view of the region here. Okay, so here's Northern California. We'll take this back to overnight. Now you should start to be able to make out the glowing nature of this. There's our smoke bank, if you will. And right here. Do you see how it's starting to twist and make that counterclockwise rotation? Now, I hope that that's just, it's just a minor thing and it doesn't go into anything further. I've never seen anything like it before. And let's get a look down to the south now. Look at California right now. This is a current view. Well, actually, here, let me get a view looking westward. Here is a current view looking westward. So that's catching the sunlight. It gives you a good view of how much smoke there really is. Look at that. Now, go back to the start of the morning. Right here. Here's sunrise. Look at the steam burst that just came off of the fire there. And it shot up above the smoke and faded down and away. And then, now I would say, let's get back to, like, this one up here to the north, that one up there to the north could be a pyrocumulus from intense heat. And same with a few of these other little small bursts down to the south. These could be, a formation of actual cumulus off of the particle. But that first blast, that mushroom cloud that comes up out of the fire, and you can see it shoot up out of the fire right here. It actually obscures the fire. That steam return, and we know it's steam. There's no doubt about it. Let's go to lower level water vapor and go back to the start of the day. Boom, there it is. Look at the intensity of the water vapor on that. And the amount of water that it would take to do that, I'm telling you, lakes and lakes worth. And it all went poof. So, what could cause that? What could cause that? There's only a few things that could cause it. And that we're looking at. Now, the beam energy could do it. We watched the Lieutenant Colonel Thomas Bearden thing yesterday, which you guys should go watch. If you missed that, go over to my YouTube channel. So beam dumps, look at that. Oh, wait. Wow, look, it catches the light first because it's so high already. Look at that. On the natural color fire view, this morning, the giant steam plume that blew off of there was so high in the first start of the day that it caught the sun first and lit up right there and further lit up. And then it had a shadow because it was so high. And that obscures the whole coast. And that's all smoke. Smog. Smoke fog. A smoky fog mixture that's forming into its own counterclockwise rotating low pressure system over Northern California right now. Again, the swirl is undeniable. The swirl of that, the swirl on this matches the swirl on this. Compare. And the counterclockwise rotation is one thing and one thing alone. We know that. So how could a smoke, well, I guess maybe just that amount of weight in the atmosphere of all the particles would cause a rotation. Weight and motion. Rotation. The planet's rotating. Wait. I'm so busy looking down here along the coast that I'm not even noticing all the other fires that are flaring out up here across all of Washington, Idaho, and Oregon, and southern Canada. How am I not even noticing that? Look at that. This is something, look at that. It's a giant ring of fires. Not counting the ones along the West Coast. Let's turn on the near or shortwave infrared. And go back to the start of the day. Look at that mess. Look at this mess. Okay, well, yeah, look, all those little fires break out throughout the day. They're blinking on and off little black splotches all the way across Washington, Idaho, in a giant ring around this. Around this. Just watch. Right there is where we really get a lot of them. Wow, it goes all the way over to Yellowstone. So it goes here, 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 up through here, down through here, around, down, and all the way down. That's a match. That's a match if I ever saw one, guys. That is a match to our plate. But that could be precipitated by what we've been watching for the past few days. As we know, energy beam drops, precipitating earthquakes and fires. It's unprecedented to see what we're looking at here. Let's go back to our natural color fire view. Here's this morning. Okay, so yeah, we're starting here. We go up, 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 here, here, up north, back down, around. It's all smoke now. And that's not smoke from these fires. That's smoke from their own fires now filling this area here on top of the insane smoke going all the way down. Now let's go just quickly look down in Southern California. Since we've been spending so much time on Northern California, let's see what it looks like down south. Here's the whole state. Actually, let's get a sub-regional view and come in from Nevada's view. Okay, this would be Salton Sea. Here's Lake Tahoe and all of Southern California. How many fires are going down there? Here is Sunrise. We have 2 fires in Southern California. There. Oh, by the way, there's the big steam burst coming in from the north with its big shadow. Wow, it lingered all day. Is that ash? Steam and ash? Phreatic burst? We have to figure out where that big plume came from. We really do. We need to figure out where that big plume came from. You guys down with that? You okay with me taking the time to do this live? Oh my goodness. Okay, let's do it. Let's do it live. Here we are. Boom. There it is. Okay, now the way we're going to determine the location, we can see where it comes up from right there. But I'm going to turn on my county lines. So let's do that. Let's turn on the county lines. Oh my God, look where it is coming from, guys. Oh my God. It's coming from the sitting camel. This county shape here, we've talked about for the last 3 years. The sitting camel-shaped county, where hot spots appeared in the hump of the camel's back last year before the fires down in Paradise. You've got to be kidding me, of all the places, man. Okay, hold on, let's get this. Let's get it. I'm going to upload this to YouTube when we're done here. It's right at the county line. So it originates right here. And then it blows up into a mushroom cloud. Okay, so if this is the sitting camel position, this would be its front legs, if you will, or where it would be sitting down. Let's go right into the middle of there. See what's there. Here's Clear Lake volcano, so we don't have to go too far. Up here. Wow, man. Borders and labels on. Here's the sitting camel position. Came from right here. Right here, guys. The big burst. Here's Oroville Dam. The big burst came from right here. Nothing marked. Nothing. No volcanoes marked. We only have Lake Oroville and Paradise, California right there. It's right to the east. Let's see how far we are east of Paradise for that explosion to take place. 17 miles, 15 to 17 miles at the most. Boom, right from here. Huge blast of some kind. Steam. And it's at the border, so that can rule out Bucks Lake, because we are on the border with whatever just took place here. Junction House, Merrimack, Buckeye, Palmetto, whatever it was right through here. What's the name of the peak? Whiskey Hill, Chute Mountain. Now, overall, we've got a few other things here right next to it. Let me just turn off our borders and labels. And I guess I need to turn off all the volcanoes. I'm going to need to turn them back on in a second, though. There we are. This. Look, I've said it before. I'll say it again. I think it's a ancient remnant of a supervolcano. It's lined with its other own smaller volcanoes. It gets hit with earthquakes all around the outside edge and in the middle. On both sides, we've got geothermal fields at the fumaroles at Pyramid Lake. And down here, we've got Steamboat Springs, the marked volcano. The supervolcano here, guys. That's what would lead to it. It's right on the back side of it. A few miles, let's measure, from the edge of the supervolcano over to our location. 30 miles. Let me turn our county lines back on. 40 miles. 40 miles. 43 miles to be exact from the edge of the supervolcano caldera. Big blast of steam. What could cause that? Well, I'd say it would probably be caused by the same thing that could cause the fires. And we know there's energy beam dumps being done, happening now, most likely also happening tonight, but it's all censored now. So there's not much for me to show you on the beams, at least not yet, and anything I see from now on is going to be questionable because they're censoring it out now. But I'll tell you, to get a big blast of steam from this location right next to Paradise, we are just a matter of miles from downtown Paradise, 17 miles from downtown Paradise. And I'd like to see how close the fire is coming to them. Because again, I mean, Paradise is like right here. I mean, the fires are reaching right down to it again, guys. The fires are like going to right here. How could we get fires at the same location 2 years in a row with earthquake activity, following or shortly precipitating or preceding? So I'll say precipitation because the earthquakes certainly might be playing into that, might have an accumulating factor of energy in the area. The particle beam thing, let's go back and check the particle feed. You know, that beam is not showing up on anything else except for particle. It's not showing up on long wave or short wave. Particle near infrared. Could it be a particle weapon? Let's look out here. Are we going to even see anything now? Wait, what's going on here? We have a glitch. Now we have a glitch. Now the satellite's glitching. Let's white it out. Let's go over to the localized sector, see if we can get a better view on that. Again, we're just trying to see the particles now. I mean, I'm trying to look at the particle, and all of a sudden the particle feed is giving us a problem. Want to go check the greater particle feed? No. It's getting to be sunset. Turn it off. Do that. I think we know where the satellite's beaming from now, right? Okay. Well, here, we'll have to wait and see, but yeah, that's just... Let me hit refresh. Nope, that is the most current image. Oh, man. Okay, well, you know what? This gets me back to where I started, which was the reason to get on was to show you the smoke and to talk about just how phenomenal that amount of smoke is. And that amount of smoke is going to be coming back in over the next several days. So when we're talking about cloud condensation nuclei, which is just a complex word to describe dust in the air that attracts moisture and forms into raindrops, that's going to be leading to a large amount of precipitation once it gets over to the Continental Divide, which is Colorado, and the Midwest. That this amount of smoke is unprecedented. We have never seen this amount of smoke, and it's so much smoke that it's forming its own low pressure system, and in my postulate, that could only be caused by the weight itself. The weight of the combined total mass of the air, because normally low pressure systems aren't hot. You don't get a hot low. I mean, you can get a dry low, but this would be caused by the weight of the material itself in the atmosphere. And it then starts to rotate, and next thing you know, you get convection. Hey, this might even lead to rain. Might even lead to rain out on the West Coast. It might not take all the time to get to the Continental Divide. I mean, if this thing really starts to rotate up. But right now, it's all dry particulate matter rotating there over Northern California. A smoke low I mean, I'm coming up with the term. I mean, somebody else will come up with a better term than that. A cumulo-low. Wait. A pyrocumulo-low. A pylo. A pylo. That might be the best terminology for it. A pyro-low. Oh, yeah, that would even be better. Pyro-low. We've never seen it before. It's the first. I'm coining the term now. Pyro-low. Remember that. Maybe somebody will start to use it. You don't have to give me any credit for it. I'm just combining terms that make the most sense. And you start to see that rotation. And it matches the rotation over the Colorado Rockies 1,500 miles to the east. And there's no direct connection between the systems. You can't say that it's this system causing this to rotate. That this rotation is on its own, separate from this rotation. And somebody should check the pressure to see what it really shows. I wouldn't even know where to check the pressure on here. Do we even have it on here? I don't think we even have it on here. Hold on. Well, that's not going to work. Well, okay, let's go to the next lab. Weather analysis tools, numerical products. Oh man, yeah, this is going to be a total cluster to try to navigate. Okay, I'm not going to do that. Let me just remind you guys, we're going to watch the storm as it blows through, the smoke storm, and we'll see if anything else develops off of it. I'm watching the fires. I'm very skeptical now on the beam information now that it's being censored. So even if a beam shows up, now that they know hundreds of thousands of people are watching, they're going to totally start to censor it. And they already did. I mean, censorship's one thing when you put a black line over it, but I wouldn't put it past them at this point to start putting in fake beams and, fake returns and, glitches and all kinds of stuff to justify. So just from now on, keep your eyes open, see if anything happens, but I think we got an answer as to what's causing the fires and the earthquakes and the hot spots and the volcanoes. That a directed energy weapon, as Lieutenant Colonel Thomas Bearden said, dumps the alternating current of the radio wave into the crust, turning it basically into direct current in the crust, piezoelectric energy. It's amazing. And then that causes earthquakes and volcanic activity on top of the fires. And, there's a whole host of other things they can do, but it's amazing, guys. I just was talking about it with my wife tonight. I just cannot believe that this is what's happening. But there it is. So the fires are just incredible and not good incredible. They are record-breaking incredible. The smoke that comes off that right now has to be the most foul and hard to breathe mix over on the West Coast, and it's covering pretty much all of Oregon and California. It's going to come our way. Oh, hold on. There's something else I want to show you. Dang. Let's go back over to College of DuPage. I want to show you how the smoke goes across the rest of the country. There's a bunch over on the East Coast right now. Just wait, I'll show it to you. So we had some mix in last night here in the Midwest and made major lightning and everything. But look over here, over Tennessee and Kentucky and Ohio and West Virginia, going down to Mississippi and Georgia. Just look really close. Right there. Do you see that ripple? That is the first blast of smoke that mixed in here, but that's the first blast of smoke from several days ago when the fires first started, when it wasn't nearly this big. Maybe I can zoom in a little closer so you can see it over here on the East Coast. We need to get the view to the south. Hold on. There we go. So watch this. You'll be able to see it again. Right there. All of this is smoke. I can tell you this. It's super hazy here in Missouri. Enough that it looks like there's fires going on here. You don't smell any smoke. It's just a thick haze. And I said to my wife, that is it. Now look, it's going all the way down to the Gulf. Do you see it down in the Gulf? And you can really tell it right there that it's kind of got that reddish tint to it. So that's just the first blast of smoke, and it wasn't even that big compared to what's coming our way. That this blast of smoke is just going to be crazy all the way across the country over the next several days. That's also what I wanted to show you. Now we can get out of here. You guys, if any earthquake activity strikes, I'll be back on at a moment's notice. Be safe. Hello, everybody. It is 6:28 p.m. Central Time on the 4th of October, 2020. It's Sunday here in the United States, and I hope you're doing well. I've got some somewhat strange breaking news to bring to you, and I think I'm going to upload this when I'm done here live on Twitch, and we will upload this over on YouTube and premiere it. You guys just need to see what's going on, and I'll let you decide for yourselves. I'll explain what I think's going on in a second here, but first things first, let's turn on a display capture so you can see what I see. And I'm going to bring you over here to GOES 16 satellite. And just to give you a perspective of some of the things that are going on, we've got big fires that have been going on out west. We're looking at the shortwave infrared view. And hotspots, or fires in this case, are going to show up as black splotches on the map. And this one's, 20,000 acres burning in southern Wyoming, just to give you an example of what a fire looks like when it breaks out on a windy day. And that's what's going on right now over here at the Wyoming-Colorado border. But that's not why I've got you on here. I need to bring you over here to the Midwest. And I'm going to show you something that I've never seen happen before. And then we're going to talk about what we think it might mean. Okay? So first things first, you just need to see it for yourself. This is today's imagery. You can go verify me on any GOES 16 viewer and turn on the thermal imaging or the shortwave infrared. And I want to focus in here right on southern Missouri and watch. Now, each one of these black splotches that shows up, I'd like to clear up first. There are no major control burns going on, and each one of these flare-offs of heat is being detected anywhere between 500 Kelvin and 900 Kelvin, anywhere between 800 degrees Fahrenheit and 1100 to 1200 degrees Fahrenheit. And they're going for 5 minutes. Maybe, or 10 minutes, flaring on and off. And I'm just going to move it back and forth. Now, this is matching with an area that we all know about, and at least have heard about, the New Madrid seismic zone. I live just west of St. Louis up here, right up here, just about 75 miles west of St. Louis. And here, down in the New Madrid seismic zone, we've got something going on with a flare-off of heat signatures. And then we can go over to Google, where I've got the GOES 16 satellite place marks for the fires that are being detected. And we can just click on some of these. This is the New Madrid seismic zone right here. New Madrid is right in the middle. I've got a place mark on it where it is. Now, I'd also like to draw your attention to all of these, which are also showing up as fire signatures. And each set of these should match something that I think many of my viewers have seen in the past, which is this, the Craton edge on the inside of it. But these are not exactly wildfires, and they're not farmers burning their fields. Again, each one's 5 minutes long, and it's a burst of heat. I'll click on just one. Here's one, fire detection centroid, good fire pixel, detected today. And look at this, 917 K, which we measured out as about 1100 to 1200 degrees Fahrenheit. And that is just one of many that's showing up here, several detected on top of each other. And it's only focused here, matching a perfect match on the inside of the New Madrid seismic zone. Now, where have we seen hotspot breakouts like this before? Well, the only other examples we have I don't have any other previous examples like this to show in the Midwest. I would have to take you over here to California, where we have all the hotspot signatures around where our wildfires are, around our volcanoes. For instance, this is a super volcano here at the California-Nevada border called Long Valley and Mammoth Mountain right in the middle. And look at the ring that the fire is making around the other side of the super volcano. And that's just one example of many. We got another one right down here. Hotspot. This is California now, where we have a ring of volcanoes, which is a caldera of an ancient supervolcano. And right next to it, we've got a bunch of fires taking place over on the West Coast in big clusters like that. Again, let's go back over to College of DuPage and look at the visible satellite imagery. We're going to go into a localized sector now and look down here first in southern Missouri. Then we'll go over to the Indiana-Kentucky border region, where the other little outbreak is taking place. I shouldn't say little, the other big outbreak of hotspot signatures. So what could cause a dramatic release of heat like it's fire, flaring off here and there across the whole southern New Madrid, southern Missouri seismic zone, and then disappear? What could cause all of that if it's not control burns, which we know it isn't, and it's not farmers burning their fields, and each one's 1,000 degrees Fahrenheit or so? It's a burst of heat coming from the middle of the N-shaped bend in the New Madrid seismic zone, which I can show you over here on my map here, which I've had on here for years, the edge of the North American craton. And in the middle of it is where our heat signatures are taking place. Now, in the middle over to the east, let's go back over to Google Earth and look over to the east. Here's the New Madrid with all its flare-offs going down the Mississippi River Valley. Now, you guys remember the story of the Great New Madrid earthquake back in 1811? When there were sudden bursts coming out of the ground, not just sand geysers, bursts of heat and steam reported. Flashes of light, too. But over to the east, this cluster matches on the edge of the Wabash Valley seismic zone. But to see the New Madrid or the Wabash, I'm going to turn off all the place marks for a second here. And again, this is the N-shaped bend of the New Madrid seismic zone. And these are foothills that go through Arkansas and back up into southern Missouri. Let me make sure you guys can see all this. And then it makes a U-shaped bend down through Alabama and Mississippi. That's the New Madrid. But going up this way like a horn or a curve coming off of the New Madrid, that is the Wabash Valley seismic zone that goes up into Ohio up here. These are the two most dangerous seismic zones, according to professionals, in the United States. So now let's compare where our fires are again. Or our hotspot outbreaks, I should say, because they're not really fires. It's a smack match for right on the west side of the New Madrid and right on the west side of the Wabash Valley. These hotspots just popping up suddenly today, and I don't have any previous examples to go on to tell you what to expect off this. Now, I live here, and I can tell you this. If I saw this going out in California like this, let's say this was happening down in another very active seismic, let's say this happened across LA. If this happened across LA, I would warn Southern California, all of Southern California, for the potential of a large earthquake. And I would look for the rest of the week, at least, for that. Just because the amount of heat that it would take to cause something like this, first of all, to shoot up through the plate, and for it to match the New Madrid seismic zone, oh man, it's just too big of a coincidence. We have to watch now for the next week, and I have to, dust off my emergency kits, because this could lead to if this is a release of heat from the plate shifting or bending somehow, then we do have to watch for the potential of a large quake. Another way to look at this is all happening about 2 weeks after the West Coast shifted. Over on the West Coast, we had a slow slip with thousands, well, actually more than 2 weeks ago, 3 weeks ago. And then this past week, another quick slip of a few hundred and 4.0 range activity, almost 5. Well, it was a 5. It was up to a 5.8 that struck down here in Southern California just a few days back. Now, all of a sudden, over here on the edge of the craton, over to the east, a sudden hotspot outbreak? Now, I'd like to look at this at visible satellite just to see. Let's go look at natural color fire, visible for the day, and hit play. So here we are last night going into this morning. There we are. We start throughout the day. There's our cold front that blew through. It's just getting cold and... Whoa. There was a flash or something there. Hold on. There was some kind of beam that just took off. Guys, there was some kind of... Hold on. What? No. Oh, no. Okay, what is this frame? October 4th, 2020 at 19:26:15 UTC. Everybody go verify this on your own version of GOES. This is a beam. Hold on. Are you kidding me? All right, we need to go look back out at a regional sector on this, on the visible. What is that? What is this funny business? Somebody put this on there. Some National Weather Service person trying to play a joke on us or something. Are you kidding me? Look, this is going down where the fire is in northern Colorado. This is foolishness. Okay, it's not, that beam is not, that is foolishness now, okay? This is, that to me looks like somebody's playing around, playing a game. Let's go hit play on this view. The regional view. I can't believe that. That is showing up as bright purple on the fire view. There. Okay, it looks like it's coming from up in Ohio. Let's go up into Ohio. Take a look. This is oh, not Ohio, Iowa. We're going up into Iowa. And this would be looking down, that's northern Missouri at the bottom middle of the screen. Okay, so this one's going, wow, look at that. Look at that. Look how it takes a step down, or maybe it's coming up. Is that, oh my God. Okay. Something is going on, guys. Something very odd that I've never seen before. Are we looking at directed energy weapons again? Is somebody playing a joke on us? This is some kind of hoax put out by the National Weather Service. What if it's a disgruntled employee and they're causing this to look like it? They're populating it from the National Weather Service office or something. Because this is official GOES satellite imagery here. Anybody can go look this up on any feed they want. I use College of DuPage because I'm familiar with it and it's easy to access for everyone. Let's go back to the shortwave and now we're just looking at shortwave infrared. And I'm going to look at particle size near infrared in just a second too now that we have some kind of weird beams populating in on the screen here. That is just foolishness. Okay, there's all our hotspot signatures, same time that the beams are supposedly going on the screen, but you can't see them because the beam is in natural color fire view, particle infrared. Let's go to particle. Now we should see the same thing, okay, throughout the day. Now, it might be a little harder to see for the hotspot signatures because it's going to accentuate the clouds a little bit more. But we should still be able to see it. There, okay, you can see these little flashes going across southern Missouri. Now, it's not showing up on particle near infrared. It's only showing up on the thermal visible view. Visible thermal view, which is so suspect. Let's go to the natural color view and just see. The chances of having the beam go down into the same area where there's a bunch of hot spots is just phenomenal because it's not like they're bright or something. People said previously, when that happened a couple of weeks ago with the directed energy weapon out on the West Coast, they said that was just a reflection off the fires. Well, these aren't visible fires. These are hotspots showing up down in the New Madrid seismic zone, and we have a big purple something or other going right down into the center of it. There, right there. But what's so weird about this is we go look at the regional view of the greater view, and the beam is going a different way on the screen. So it's going west and east there. And there. Okay, now it's... okay, maybe we were just lagging a few frames behind. Okay, I mean, what do we want to make of this? Should we go look and see what's up here in North Iowa? See if there's anything there? Because I would think this would be up in space, beaming down at an angle. And it would be more like over Missouri, beaming down. Or it would put the craft or whatever it is somewhere up here in between here and here. And it went from here to here. Either way, we've got a bunch of hotspots showing up at a time where there's a beam going down into the area. It can't be chance or coincidence. This is now bright purple on the screen. What does that even show? What is our color key on this? Well, I can tell you for certain that the color key won't cover directed energy weapon beams, at least not yet. We'll have to add the Dutch sense mode to this viewer for that. But maybe they should make it a rainbow color and add some sound effects for this dang thing. Let's go back over to the natural color fire view. The chances of having it shine down in there is just so phenomenally, insanely low for it to just be chance. Or insane high chances. It would be almost impossible for it to be chance is what I'm getting at. So either somebody's totally trolling us from the National Weather Service and populating in fake data, populating in fake hotspots, populating in fake beams, but now we're getting to a level of conspiracy. And I'm talking conspiracy amongst people at the National Weather Service to try and hide something or goof around or troll us. How else would you explain it? You couldn't have that many coincidences. You couldn't have that many accidents. And so something's up. And that then leads me back to what this could be. I mean, if it's not a troll, if it's not a National Weather Service hoax, but if that is, that's troubling. Everybody should get fired. If they're hoaxing using official stuff, I mean, you guys go look this up. Our date and timestamps are down here at the bottom of the screen. So let me just pause it and get our date and timestamps so you guys know what to look up on. You can use visual. There's our first there, right there. And that comes in at the 4th of October, 2020 at 17:06:15 UTC. And this is on the regional view, but let's go to the continental view. Let's do the whole continental view here. We've got a bunch of smoke from the fires out in California. So what's going on? Are they hoaxing us and then putting in a bunch of hotspots down in the New Madrid to scare us? Wouldn't that be crazy? Which is more crazy? For them to try and hoax us and try and scare us that way, or for this to be real? There. Oh, look, it's going through the clouds. It looks like it's going through the clouds, doesn't it? Here, let me zoom back in on that, because let's go back up here to Michigan. Or is that just waving out? I mean, if that is just waving out, then that's a wave of some kind of energy beam, because it would be oscillating, and oscillating would go in and out of the spectrum that's visible on this near infrared and visible view. Okay. Wow. Look at that. Look at that. I mean, if somebody's faking it, what is over there in Lake Michigan or in North Iowa? North Central Iowa. Let's turn on our borders and labels and just kind of zoom in around there and see if there's anything weird up there. What do we got up here? Oh, man, I'll tell you what. I don't know what to make. Oh, up there. Look at the name of the place. Oh, my God. Yeah. Okay, we're out of here. Let's go over to the east. What's over here? Hey, look, a hotspot signature. A fire detection centroid is there off of Lake Michigan. It's within 20 miles. Here's the fire detection centroid. And here's our peninsula that goes out to the west in Michigan. And we get back over to Google Earth. Here's our peninsula that goes out over to the west in Michigan, and that might be 50 miles to the south at the most. Again, like the beam's coming into right down here, and the hotspot's right next to it. There's only 2 in all of Michigan. That cannot be a chance. There's a hotspot signature right where the beam is coming in there. And here in Iowa, or actually up here in Iowa. Wow. And there is a hotspot over here in western Iowa right next to it. Now, Mason City is over here on the east. I want to see, but it would be above it, I think. I think this would be up in space. You would think, unless they're beaming this up as a high-powered microwave and reflecting it off the upper ionosphere and back down again with an artificial spheric mirror reflector. But that would require a lot of knowledge on radio waves and plasma physics to do that, and some facilities. Let's hit play again and just look across the whole area. This is on our natural color fire view. If it is a mistake, it's the biggest mistake in the world to have it go into the same spot where we're having all the hot spots. So I think we might be looking at something going on here that's legit. Something like that, beaming down into here, and then right next to it, the New Madrid seismic zone. Imagine this at an angle now. You've got to imagine this like something way up above here in space, beaming down and out. And it does look like it's going through the clouds. It really does. I mean, it could be a mistake. Look, there's a yellow line coming off of this one. Now there's a yellow line coming in and going down into, oh wait, it's shooting down into the spots that are the hot spots down in southern Indiana that are detected. Let's go back down here and look. How close are we? Oh yeah. Yeah, look at this. And then we go back over. You might not be able to see the yellow beam here, but it's very hard to see. Let me zoom in on the area. Oh my God. I cannot believe this is happening. Because, I mean, for me to catch the first round. Okay, there's our first. It's scattering out. Somebody's either trolling us or that's legit. There it is. There's our yellow beam coming off of the purple beam. And it's going, if we were to follow this straight down in a line, it goes right down to where all those hot spots are. And again, I'm looking at this 3-dimensionally. So again, if it's shooting down this way and it's going right down to here, and the other beam is shooting right down to here, and it right next to it, all the hot spots. And the East Coast. I haven't even checked all the way up here in Maine and Pennsylvania yet, but I probably should. At this point, we're going to need to go over to Maine and Pennsylvania and see what the deal is there. And hit play and just see if anything shows up. This is the most wild adventure that I've ever been on. Oh wait, hey, look. So the beam comes over and we can't see it anymore. It disappears either into the clouds or fades out, but you can see how the beam takes a step down as it goes in to a finer point. Or maybe it's expanding. Maybe it's coming from the ground there, going up and expanding and coming back down. But if you were to follow this trajectory over to the east with the curvature of the Earth, look where it puts us. Puts us in New York. And then we get back over here and look at the fires. Well, there's New York. We got a bunch up there in New York. So what about the one in Pennsylvania? Well, let's just take a look. See if it goes any further. Oh, yeah. The second transmission, if you will, or troll. Either we're getting trolled or this is real. I'm not doing anything, by the way. I'm just showing you what's going on. But this is alarming to me now as we go back and go over to the shortwave infrared and look down in southern Missouri. Even at this height, we should be able to see all of these hot spots, these little flare-offs of heat down in southern Missouri, down here in the New Madrid seismic zone. The cloud cover is obscuring whatever's going on at the Indiana-Kentucky border region. But I am worried about that. Look at over to the west, all the oil wells flaring off. Over in Kansas, Let's go over to Kansas and take a look really quick because additionally we have oil wells flaring off. So this is Kansas, Oklahoma, and Texas, and Arkansas, and Missouri. So this should show us all the oil wells flaring off. Watch this. Something's going on. They don't normally flare off unless they've got something, they're trying to get rid of a lot of gas, or there's some kind of overpressure that's going on. Yeah, look at that. So across Kansas as well, all the oil wells, they're venting off in central Kansas, and it looks like down into Oklahoma. With a few in Arkansas as well. So in addition to the New Madrid seismic zone, we've got oil wells flaring off. And to give you an example of something that normally flares off all the time, we can go down into like Texas and look up here in West Texas at the oil pumping operations, and you'll see these flare off a lot. There's tens of thousands, if not hundreds of thousands of oil wells. So just wait for it for a second here. Throughout the day today. Oh, of course, you can't see much. Of course it's not showing. Okay, normally we could go up into North Dakota and we might be able to see some. Let's see. Does it show? If they're not, yeah, they are. Okay, you can see a few up here in North Dakota at the fracking operations. They're a little hard to see, but they're the same size. They're the same flare-off shape. So I'm going to tell you guys right now, this is something I have to keep a watch on here in the Midwest at the New Madrid seismic zone. I'm not going to issue a forecast. I don't have any previous examples to go on like this, where we're getting a bunch of hotspots just in the New Madrid and then on the Wabash Valley seismic zone and on the edge of the Craton up to the east by northeast. One more time, the edge of the Craton. And if you compare the edge of the Craton to our hotspots, the red dots are the hotspots. So New Madrid, here, let me get this in view. New Madrid, Wabash Valley, edge of the Craton up at the Pennsylvania-New York border region, and all the way up here at the Maine-New Brunswick border region. It's a perfect match of hotspots going all the way across the edge of the Craton. Now, here's the deal. Somebody could be trolling us at the National Weather Service. It's possible. But for it to be a match, I mean, I'm not going to discount the possibility that there could be somebody that's, just playing around. But to have that level of, it would mean they would need GOES 16 access, they would need the fire detection Centroid access, and they would need to not be concerned with causing a fire panic for people because everybody can use these feeds and see what's being reported. Now, seismically speaking, what could cause this? Well, the edge of the Craton could be being pushed. The whole plate could be in motion right now, in which case we should see an earthquake somewhere near where these hotspots are. And the hotspots are going from the New Madrid seismic zone to the Wabash Valley seismic zone, up the east coast, all the way to Maine on the edge of the Craton. That would mean somewhere between Maine and the New Madrid, we should have a big earthquake very soon. And when I say very, I guess I should say we have to use the past examples in California, where the hotspots show up in clusters, and then next thing you know, within a week, 2 weeks, we're seeing major outbreak activity, whether it's swarms or 4s or 5s. We've even seen some 6s pop off before in the past out on the West Coast when we get a lot of shifting. Now I can tell you this also. Here, hold on. Let's get another display capture open. And let's just quickly go over and show you where we have other hotspots that show up. But I'm going to show you something from the PNSN tremor map, Pacific Northwest Seismic Network tremor map, up here in the Pacific Northwest. And we'll go back to the second, and these little red dots. These are vibrations as the plate shifts, but we see explosions, hotspots, and fires breaking out next to where we see the shifting. We've seen that over the past several weeks and months. So does this mean that we're going to have seismic activity come rolling into the Midwest here very soon? I hope I'm wrong. Hope this doesn't mean anything. But the DEW, the directed energy weapon beam aspect on this, is so odd. Well, it's more than odd. It would be twice now that we've seen this happen in the past few weeks. But this time, it's so visible, it's showing, the computer is detecting it. Either it's a mistake, a troll, or it's real. And at this point, with the hotspots being mixed in, we would have to think that it's a troll or it's real. That the mistake aspect kind of gets thrown out the window when you have the hotspots, the actual fire detection centroids being showing up at the same time the beam is there. Okay, I'm going to save this as a video, and we're going to upload this over on YouTube. We're going to keep a close watch over the next 7 days for the next week, and probably for the next 2 weeks, but just to keep it in a 1 week aspect, I'll watch from today till the 11th. And at the 11th, we will reassess. We'll see if this carries on, or if it transfers, or if there's any explanation that turns up. But my radar is going off like you wouldn't even imagine. And I live here. I live right here. Okay? And I got the Michael Brown shooting on there. I grew up in Ferguson, by the way. I'm Mike from Ferguson. How ironic, right? Okay, you guys, much love. Will you have an earthquake plan? And I really mean it now. Will you please take the time to develop an emergency kit? And I'm going to go through mine. So I'm going to go through my emergency kit. And I will tell you also, you need to know what to do in case you get displaced outside of your house. So if you're outside, you might not be coming back in for a while. So you might want to have an additional amount of supplies that you keep maybe in your car or your truck, or maybe even in a trunk buried outside if you have to. But a way to keep things that you need for the next several days of a disaster if one takes place. Now, I haven't even gotten into the rest of the earthquakes that have struck. This is not really an earthquake update. But as we're scrolling by here on the screen, you can see all these fives that have spread all the way across the plate. This is within 48 hours. So the rest of the Pacific plate is in overdrive. Again, look at our 5s and greater, or 4.9s and greater, in the last 48 hours. The whole West Pacific from Kamchatka across Japan, going down through Philippines, back all the way over to Fiji, all has already moved. Our volcanoes are increasing. Australia moved as expected. Central Australia, Southwest Australia, Southeast Australia. We're still waiting for Northeast Australia to move, but the rest have already moved. Check them all off the list. They were all warned. Europe even started to move pretty heavy this week. UK, Scotland. Scotland got hit up here. We have a volcano to the west of here. And Scotland got hit. But I'm here to talk about this. If my neck of the woods gets a new earthquake, and by the way, look where all the rings overlap. Right on the edge of the craton coming out of Oklahoma and Arkansas, going up into the New Madrid seismic zone. To top it all off, throw in the directed energy weapon aspect, and we've got ourselves a full freaky deaky thing going on. Figures I would get thrown this to catch today. Be safe, guys. Peace out.